Gas chromatography, the substance to be analyzed is partitioned between the mobile and stationary phases. During the separation, the sample is vaporized and carried through the column by the mobile gas phase, that is the carrier gas. The different components get separated based on their vapor pressure and affinities for the stationary phase. The affinity of a component towards the stationary phase is termed as distribution constant, that is Kc, which is also known as the partition coefficient. Movement of different components through the column is controlled by the distribution constant Kc. Thus, the chromatographic separation occurs based on the differences in distribution constant. The separation of compounds in a mixture is based on different polarities in a direct way, that is by interaction with stationary phase, based on solubility, or indirect way, that is by physical properties like boiling point. The gas chromatography column consists of solid support that is covered with a high boiling liquid in a thin capillary tube. In the example, compound X has a higher affinity towards the stationary phase compared to compound 0. Compound 0 elutes before compound X because it displays a lower boiling point and a weaker interaction with the stationary phase. Temperature managers in gas chromatography, BC. In gas chromatography, temperature management is critical for achieving effective separation, resolution, and analysis time. The primary temperature manager is the GC column oven, precisely controlled chamber that houses the chromatographic column. The two main operational modes for managing column temperature are isothermal operation and temperature programming. First, isothermal operation. Here the column oven is maintained at a constant, single temperature throughout the entire chromatographic run. This method is ideal for separating sample mixtures where all components have a narrow range of boiling points. For less volatile, higher boiling components, isothermal conditions often lead to excessively long retention times and significant peak broadening, resulting in poor resolution and long analysis times. Second, temperature programming. The column oven temperature is increased gradually or in steps during the chromatographic run. This dynamic temperature change is essential for analyzing complex samples. Benefits of temperature programming are improved resolution. Lower initial temperatures effectively separate low boiling components, while the subsequent temperature ramp ensures that high boiling components elute in a reasonable time with sharp, distinct peaks. Faster analysis. It significantly reduces the retention time for less volatile components compared to an isothermal run, shortening the overall analysis time. Consistent peak shape. Less volatile compounds elute with relatively narrow, symmetrical peaks, increasing the sensitivity of detection. First, packed column. Column are made up of glass or tubes of stainless steel, copper, or aluminum. Columns are available in a packed manner. Packed columns contain a finely divided, inert, solid support material, commonly based on diatomaceous earth, which absorbs liquid used as stationary phase. Most packed columns are 2 to 20 meter in length and have an internal diameter of 1 to 8 millimeter. The ratio of the volume of the stationary phase to the mobile phase, Vs by Vm, for the column ranges from 10 to 20. The No of theoretical plates per foot length of the column is 100 to 1000. Advantage of packed columns: larger sample capacity. Disadvantages of packed columns: less applicable fixed gas analysis, lower column efficiency than that of capillary column. Second, open tubular or capillary column or Golay column. Long capillary tubing 10 to 100 meter or more in length. Uniform and narrow diameter of 0.025 to 0.075 centimeter. Inner layer of capillary is coated with a very thin film, about 1 microliter, the liquid, which acts as stationary phase. The ratio of the volume of the stationary phase to the mobile phase, Vs/Vm, for the column ranges from 100 to 300, which is the main reason behind its high efficiency. The loading capacity is less than 0.01 microliter. Is made up of stainless steel and form of a coil. Disadvantage: more sample cannot loaded. Capillary column are of 3 types: coated open tubular, WCOT, support coated open tubular, SCOT, porous layer open tubular, plot. Wall-coated columns consist of a capillary tube whose walls are coated with liquid stationary phase. Support-coated columns. In support-coated columns, the inner wall of the capillary is lined with a thin layer of support material such as diatomaceous earth, onto which the stationary phase has been adsorbed. SCOT columns are generally less efficient than WCOT columns. Both types of capillary column are more efficient than packed columns. B. Porous layer open tubular column. Plot columns contains a porous layer of a slid adsorbent such alumina, molecular sieves. They are well suited for the analysis of light, fixed gases, and other volatile compound. C. Fused silica open tubular column. They have much thinner walls than glass capillary column. The strength is given by polyamide coating. They are flexible and wound into coils. Advantages are more physical strength, flexibility, and low reactivity.